Hello everyone, in this video I would like to talk about week 9 assignment. Before we talk about the questions, let's review what midpoint theorem and intercept theorem are. Although the answers are easy to get, these two theorems are easily mixed up, and the presentation of these two theorems will be a little bit challenging, because for these two theorems, every time you have to state the premises and also the conclusion. What's meant by premise? It means if or because something. What's meant by conclusion? It is the final therefore statement. It means then. Okay, so for midpoint theorem, what is the given condition or what is the premise? It is two midpoints. Remember, I usually call this midpoint theorem, I call it double midpoint theorem in my mind, because to remind you that there are actually two midpoints given. So we have AB equals to BD and AC equals to CE. This is called the if premise. And then what can you tell? You can tell two things. The first thing is that BC must be parallel to DE. It means this one. The second thing is BC must be half of DE. It means if BC is x, then DE would be 2x. Also, for both of them, you can claim it using the recent midpoint theorem. Okay, so for intercept theorem, remember the premise now is one midpoint and parallel lines. Okay, so you can look at this diagram. You have three parallel lines here. It is the given condition. And also, if I have a line cutting through these three lines, if I know that these two intercepts are the same, it means AB equals to BC, then what can you tell? You can tell that as long as you have another line cutting through these 3 points, just a random line, then you have dot E equals to EF. So this is called intercept theorem. For the second case, if the two lines join at one point A here, the given condition is two parallel lines and then AB equals to BC. Then you can make the conclusion that the other line also will be cut into two equal parts, which means that AD equals to DE. Alright, so later when I do the questions with you, I will show you how to present. You have to state very clearly because of what, and then therefore what you can tell, using the reason afterwards. Let's look at number 1 now. You are going to find x. So you can see that there are two midpoints given for you, AB equals to BC, AE equals to ED. It means that you can make use of the midpoint theorem stating that x is 2 times of BE. So how do you present? You have to state the premises, which are AB equals to BC, AE equals to ED. Why you can claim that? Because they are given for you. Then the conclusion would be CD would be 2 times of BE. And then after that, you have to state the reason for this conclusion, which is midpoint theorem. So this is the structure of mathematical presentation in geometry. Finally, you can calculate x by 2 times 5, which is 10. Don't write any cm here because you already have cm in the diagram. For number 3, note that for midpoint theorem, there is nothing that you can tell directly about the angles. There are only two conclusions related to midpoint theorem, which is parallel lines and also doubling the length. So there is nothing related to angles directly. So you have to use the parallel lines and then corresponding angles to find out B. First, we write out the premises, which are the two midpoints given. And then the conclusion, this time we choose BE parallel to CD only because it is the only thing that is relevant. I do not need to write CD equals to 2BE. Of course it is correct, but it is not relevant. So I just need to write this and the midpoint theorem to explain that. Next, you can calculate angle A by E by angle sum of triangle. And then using corresponding angles, BE parallel to CD, then you can find B. So I give you the structure here. I don't want to give you the full answers. So please try on your own. Now let's look at number 10. Your goal is to find angle BOID.C and look at the given conditions. You have two midpoints, B as the midpoint of AC, D as the midpoint of CE. It means that you can associate with midpoint theorem. It means BOID should be parallel to AE. So this will help you find the angles using corresponding angles. Now you can look at angle BOI.C and angle AEC. These two angles should be the same because of corresponding angles BOI parallel to AE. It means if you can find out this angle, then you are done. So how can you find this angle? You have a parallelogram on hand. It means that AF parallel to CE and also A dot parallel to FE. So you can make use of this to find out the angle. I suggest you to find out angle AEF, which is equals to 30 degree, alternate angles A dot parallel to FE. And then you can find out the question mark here by interior angles AF parallel to CE. So after that, these two angles will be the same because they are corresponding angles BOI parallel to AE. So you try to present on your own. I show you some of the steps. So these are the steps and the structures that you can follow if you want some hints. Of course, you are welcome to present in your own way. For part B, your goal is to show the area ratio of these two triangles. So how is it related to the lengths? I hope you still remember in chapter 7 we talked about the dimensions, and the area ratio would be the length ratio square. It means that if you can prove that these two triangles are similar, then the length ratio square would be the area ratio. How can you prove that these two triangles are similar? Obviously, you can make use of the interior angles. The first one is common angle. Second one, due to the corresponding angles of parallel lines. Third one, you can use angle sum of triangle, or you can use corresponding angles of parallel lines. So you can make use of AAA to prove for the similarity of the triangle. For method 2, you can make use of ratio of two sides included angle, because originally you already have AC equals to 2BC, CE equals to 2CD. Also, you have the common angle. It means you have ratio of two sides included angle. So you try to present it in your own way. After you prove for the similarity of the triangle, then you can say required ratio is the length ratio square. Remember, for the final answer, don't write in fraction form, you should write in ratio form. That's all. For number 13, I will just give you the idea and you try to present on your own. So how do you prove that EDF equals to ECF? Look at the diagram. It seems to be the two opposite angles of the parallelogram. But is it a parallelogram? I mean, is DFCE a parallelogram? If you can prove that, then everything is correct because you can find it by opposite angles of parallelogram. So your goal is to prove that .ECF is a parallelogram. How? You can make use of the midpoints. Now you have 3 midpoints on hand. Depending on which 2 midpoints you are looking at, then you can prove 2 parallel lines. For example, if I look at A dot equals to dot B, AF equals to FC, then we can make use of the midpoint theorem to prove dot F parallel to EC. Secondly, if I look at BOI dot equals to dot A, BOI E equals to EC, then I have another pair of parallel lines, which is dot E parallel to FC. Because of the 2 pairs of parallel lines, we now can say dot ECF is a parallelogram. What is the reason for that? There should be no reason because it is a parallelogram due to this definition. As long as you have 2 pairs of parallel lines, it is a parallelogram by definition. So there should be no reason. Finally, you can use this reason to claim the result. Angle E dot F equals to angle ECF. Question number 8 of exercise 8.7 is a very typical question. It involves both midpoint theorem and intercept theorem, so don't mix up. Note that the given conditions are some parallel lines and 1 midpoint. It means that originally you have no double midpoints. You can only use intercept theorem at the beginning. If you want to claim that x equals to 8, you have to state the premises, which are A dot parallel to BE parallel to CF, and also AB equals to BC. Of course, for this case, you can omit CF because these 2 lines join at one point C. So the premises are 1 pair of parallel lines and then 1 midpoint given. And then the conclusion is CH equals to HG, intercept theorem. You can claim x equals to 8. Similarly, if you want to find Z, you can say A dot parallel to BE parallel to CF, and also you can claim the midpoint AB equals to BC. Then you can say Z equals to 5, or you can say dot E equals to EF intercept theorem first. So here are the steps. So now we have more than one midpoints on hand because we have proved CH equals to HG already. So we have double midpoints. We can make use of midpoint theorem to prove y equals to 2 times 3. So this time the premises are AB equals to BC because of given, and then GH equals to HC because of proved. And then you can claim the reason afterwards. You can find out y equals to 6. For number 10, I will only give you the idea. So look at the diagram, you have found some given conditions. The first given conditions would be related to midpoints. So you have two midpoints on hand, which are BC equals to CE and boy dot equals to dot F. It means that you can show that CD parallel to EF. Also, AF parallel to EF, it means that you have A boy parallel to CD. Why? This is step 1, you can use midpoint theorem. And then after you have A boy parallel to CD, also you have one more midpoint, which is boy dot equals to dot F. Then what can you claim about the length? You can claim that AC equals to CF because of intercept theorem. You may refer to the idea here and write in your own steps. For part B, now you have some midpoints, which are BD equals to DF, AC equals to CF. Then you can claim that one length is 2 times of the other length. It means that AB is 2x, then CD would be x. And then you can use midpoint theorem again for triangle EBF. Then you can claim that EF would be also 2 times of CD. So you can make the conclusion that AB equals to EF. For the last question, part A, you are going to prove for similar triangles. I want you to develop a sense that as long as you have a pair of parallel lines, if you have two intersecting lines and also cut these two parallel lines, then there must be similar triangles because you at least have two angles equal using alternate angles equal or using corresponding angles parallel lines. Okay, so you have two angles, and then the last one would be vertical opposite angles or just use angle sum of triangle. So it is easy to prove that the two triangles are similar using AAA for part A. Part B is a very challenging question because the formula that you are going to prove is just a formula. It means that it doesn't give you a lot of hints, but I hope you will try it. I try to make some relationship about these lengths. This is our goal. And looking at the diagram, I can see there are some midpoint theorem and some intercept theorem. So I would like to give you some hints, but you have to combine everything yourself. First, you should note that GE parallel to BA and also F is the midpoint. It means that G is also the midpoint by intercept theorem. The second thing, you can note that these two angles are the same, and also you can claim that the angle ABD is equals to angle DEF because of alternate angles. So you can see that now in the triangle BEG, these angles and these angles are the base angles. It means that you can make a conclusion that BG equals to GE because of size opposite equal angles. Next, because you have two midpoints now, F is the midpoint of AC, G is the midpoint of BC, then you can also claim that GF is half of AB by midpoint theorem. Now you have two equations on hand, and you look at the final equation you are going to prove. You only need EF, BC, and AB. So you look at BG, this is actually half of BC. It means that you can change BG into half BC, and then you can look at GE now. GE is EF plus FG, or GF, EF plus GF. So you can put this 1 over 2AB into GF, and then EF you can keep it. So you can see that after you combine everything, you only have BC, EF, and AB left. It means that very soon you will get this formula. Also, these are all the hints I'm going to give you, and you try on your own for these very challenging questions. Okay, that's all for the video. Goodbye.